department and to the CERN data center. It's actually just in our back, right there. So we have a connection via video conferencing with Zoltán Institute in Hungary. So hello, Zoltán, how are you? We will let you just introduce yourself briefly if you want. Or then we'll do that a bit later. So my colleague and I will be there for the whole tour. So basically we'll have 20 minutes tour at first and then 20 minutes for questions and answers. And we encourage you, of course, to actively participate in this. We have also people joining us via webcast, so thanks a lot for doing so. And we propose to just introduce ourselves now briefly. So I'm Mélissa Gaillard. I'm the CERN IT Department Communications Officer. I'm working at CERN for 8 years, and it's a pleasure to be there tonight.
Hello, my name is Jaroslava Schovancova. I'm a staff computing engineer in the IT department. I work in the computer monitoring group. And our, let's say, core business is to make sure that CERN can compute, can provide computing resources like processors and batch systems to the whole department and to the whole CERN. And also that we can monitor the resources, not only the resources at CERN, but also monitor and provide monitoring infrastructure for monitoring of sites or computing sites which are distributed worldwide.
Yes, thanks, Jarka. So actually, I'll go then to the next thing. So what is the program for tonight? So first, we'll have 20 minutes for the tour. So we'll go first with some time travel. So how computing started at CERN, and then we'll see what we're doing now, what's the role of the CERN IT department, and last, the CERN data center. So during the tour, you'll see that there will be many videos with subtitles. The numbers are moving very fast. We are in a fast-changing environment, so the numbers we will be giving you verbally are actually the updated ones. So I don't know if Zoltán Institute wants to introduce themselves, otherwise we'll do it at the end for the Q&A, which will be great as well.
Just a couple of things. Can you please speak a little bit slower?
Sure, okay.
Sorry, because it's not going to be easy to follow. And there quite a number of people, but it's not visible. So I would like to make sure that there are some people listening, but it's not really visible on the camera.
Sure, no problem. Thanks a lot.
Second, then I will announce you just that it starts, and that's it. Okay? So just 2 sentences in Hungarian.
Yeah, please do. So let's start for the time travel now. I propose that we start with Jarka.
Okay, so in the 1950s, before the electronic computers were used, scientists had to do all the calculations by hand on paper or on whiteboard. And it was really very time-consuming, and it was really lots of work. So fortunately, between the 1950s and 1980s, so about 60, 70 years ago, there were first computers which were really very big. They were big like a small family house. And we had to fit such big computers into the room, which is behind us, inside the data center, and perform the first calculations, which took some effort to make the calculations, but it helped the scientists really very a lot. And over the years, the data center evolved. It moved from one building to another. And the mainframes, the computers inside, also evolved. They were shrinking in size, starting from a small family house to a cupboard which you have in kitchen, through miniaturization to the personal computers which you have at home. So in the early 1990s, CERN switched from the mainframe computers, which filled the whole building, into a set of personal computers, desktops, which you probably have at home. And these desktops are organized in the racks. You can see colleague trying to push very small box inside the rack. And this is how the computing center works now. We have computers which look like desktops, which are very thin, and we use them for calculations of high energy physics, computations and data analysis.
Yeah, and then we'll also give you speak about what we're doing now. So what's the role of the IT departments now? So the role of the IT departments is to provide the information technologies for CERN to fulfill its mission. So I will put a small video just to accompany this. So let's go to the right one. So we have actually in the department over 300 people from 21 member states out of the 22 we have. And these people include implementation, operation, support of the computing infrastructure and services. Here we can see actually exactly where we are. We are in building 513. So it's the red dot on the video. And so the people working in the department are making sure all the services and the infrastructure is working for the departments for the experiments. So it's many, many services, actually, more than 50, far more than 50. So IT research and innovation is key and vital to support CERN search for answers about the origins of the universe. We have over 10,000 scientists who collaborate with CERN. You can see in blue on the map, more than 100 nations, 600 institutes. So it's really a very big collaboration. And when you have such a big collaboration, of course, it's key to be able to communicate. And this is one of the reasons why Tim Berners-Lee in 1989 invented the web at CERN. So it was to help share information and collaborate. So it was made free and open. And here you can see actually the proposal made by Tim Berners-Lee. And there is a little anecdote at the top. You see vague but exciting. And that was what enabled Tim Berners-Lee to develop the web here. It was from his... we'll pause maybe a bit the video because we're going very fast. And I think it would be good to slow down. So all the data that are produced by the experiments at CERN come to the data center that is in our back. And here on the video, you can actually see the LHC ring, so it's the main accelerator with the 4 experiments. So you have LHCb, Atlas, Alice, and CMS. And you see the data flow coming to the data center at the top. And this represented, for instance, in 2015, so last year, over 40 petabytes of data. So it's difficult to understand what is 40 petabytes of data, over 40 petabytes of data. It's actually 9 million DVD movies. So it's really something huge. And that represents only 1% of the whole data that is produced because the rest is filtered and is not kept. So when we have such a high level of data, I think we'll put the video back. It's really a challenge to manage it. And then how do we do that? We have to do research and innovation, and then we partner, of course, with many institutes, and we have as well public and private partnerships, and CERN Open Lab is a very example of that. So education is one of the 4 strengths for CERN. So we work in close collaborations with other research institutes. We have the CERN School of Computing, for instance, as well. We provide advanced training. The people who work at CERN come back to their home countries and share the knowledge as well. There are many schools organized in many countries. We have open initiatives. Maybe we'll pause again a bit if it's possible, because I think it goes very fast. So we have tools like Zenodo, for instance, and Invedio that have been developed at CERN to organize, share, and preserve digital files, and that are used by all the community, but which are freely available, for instance. And we have as well other tools like the webcast that we're using today and the video conferencing. Here on the picture, the video actually, you can see the conference, the CHEP conference in 2012. It was the Higgs announcement the discovery of the Higgs. And you see the room, so there were 500,000 single connections actually, and 700 people participating to the video conference. And here you can see Peter Higgs and on his side, François Englert. So, of course, webcast opens up a window to scientific knowledge for all kinds of people, so pupils, scientists, and as today, just to share some time to discuss what we're doing and hopefully give you a better understanding of what we're aiming at doing. And now, Jaka will speak to you about the data center, which I think is really the thing you are expecting.
So can you hear me? So the CERN data center is really the heart or the brain of all the, not only scientific computing, but also computing for the administrative, all the emails, all the systems for administration of the lab are stored or operated from here. The building, actually, there is one building with 3 different rooms. The rooms have a very, very broad floor. One floor is 1,400 square meters, another floor is 1,200 square meters, and the third floor is 200 square meters. So it's like maybe 14 to 2 flats in one space connected together. We have also not only one data center, but we have also secondary or second part of the data center is in the Wigner data center in Budapest. So you may probably see the data center yourself. This is because we would like to minimize the possibility of data loss. So we need to have duplicity, and also we cannot have all the compute power which we need for processing data from the experiments in one place. It really doesn't fit because the power consumption is enormous. The power consumption is about 3.8 megawatts. So it's something like each time which we connect to, or each second which we run the data center, it's like power consumption of 3 families per year. Yeah. I'm sorry for small technical issues. We will continue. So in order to connect the power center, to connect the data center to power grid, we have some connectors from high voltage to normal voltage of 220 volts. There is a backup of the very most important resources of the data center. So we use batteries as a backup and diesel aggregators as a backup. We also use these batteries to protect our equipment against short power cuts. Short as in much less than a fraction of a second, or like milliseconds and so on. Since the temperature in the data center is about 32 degrees, and computers cannot work very efficiently when they are too hot, like 50 or 60 degrees. We have a very good system of cooling. We have some heat pumps which cool air and cool water, and we use water and air to cool our equipment, to cool our computers, to cool our disk systems. You could have seen that there are some small racks of computers, and the cooling they are actually enclosed from the all data center. So the cooling runs inside, so that we have to cool small volume than the whole data center. What concerns the power consumption, as I have said, the data center processes 2 petabytes actually of data per day, which is something like 450,000 DVDs. This is really lots of movies. And we take the data from the experiments, from the LHC collisions. Then we transfer the data from the experiments. We read out the detectors. We transfer them to the data center, and there we process it. We replicate the data so that we have backup copies, and we export the data outside CERN using worldwide LHC computing grid. Okay. This is how the equipment inside data center. Now you can see the tape robots. These are robots which save data to the tapes. You can remember the magnetic tapes from your like 10 or 20 years ago. You could have played music on your Walkman, and you put tape inside, and the tape stored the data. So we use this media because this media is very cheap, and it can consume lots of data. So this is one of the storage ways. We also use spin disks, like hard disks, and SSDs to store the data and to cache it. But we do not store data only at CERN. We distribute it worldwide so that everyone has multiple copies of the data. Now, CERN is connected to a very fast network, and with the data center, between the data center in Geneva and data center in Wigner, there are two very powerful network links of 100 megabits. Usually at home you can have several tens of megabits, and then you have really fast internet. As I have been saying, CERN is in the middle of the worldwide LHC computing grid. And the worldwide LHC computing grid is a set of over 170 data centers distributed at scientific institutes which take part in the LHC experiment science. So in each of those institutes, you can have some computers like with processors and disks. At some of them, you can have also tapes. And there, all the physicists, not only at CERN, but also at these other data centers, they process the data, they analyze the data, and they produce physics results of very high quality and very fast. Now, each day, WACG, so these distributed data centers all over the world, calculate over 2.5 million jobs. One job is, let's say, computational job is something which physicists uses to analyze the data. So it's a computer program which is running at these distributed sites at one site at the same time. And it's doing something. For example, it's analyzing the data, or it's reducing the data to make the output file or the output more usable for the analysis, or less large. Now, CERN contributes to about 15% of all the worldwide LHC computing grid resources. Worldwide LHC computing grid provides over 500,000 of CPUs, and it has several hundreds of petabytes of data of storage for the LHC experiments data.
It's really distributed everywhere, as you can see.
And one of the reasons why we are distributing all the data is because CERN cannot contain all the computer resources at once. It would be not possible because of power requirements. It would be very, very expensive. So in this way, the institutes are sharing costs of the science making, of processing the data, analyzing the data.
Yeah, thanks a lot. We'll have the chance to go through that into more details during the question and answers. So we can show you as well some videos to explain some of these aspects and go into more details. We'll go slowly as well because we've been very quick. So that would be really nice to have a really an interactive session. So I propose that we go to the Q&A one section now. Do you have some question on site at Baselton? Hello.
I'm asking the audience whether they have any questions.
Sure.
It doesn't seem to be the case. I'm sorry.
Yeah, maybe you wonder why you see in our back there is a very high ceiling. You may be not seeing it, but it's very deep. And that was maybe that's something some of our visitors ask very often. So it's really an impressive room. And we can show you, maybe we have a video of the overview of the data center a bit further. So we'll show that to you. And as my colleague said, this building was built in the early 70s. And at the time, we had mainframe computers, which were really very huge computers, the size of a cabinet. And then you needed to have cooling by actually the ceiling. It was going vertically. Now it's going more horizontally. And you needed a very high ceiling at that time for this reason. So now, actually, computer centers have a very lower ceiling, so that it's easier to cool than the racks, which are, the cooling is going horizontally for this thing. So maybe we can show you, we have a video of that. So I will go through it and find it. It's here. So here we can put maybe the, yeah, can you put the presentation? Yeah, that's great, thanks. And so here you can see the room. And then we'll show you a video with the, it's not going, I will click. And then you see a bit better the room. It's the main room, so it's the 1,400 square meters one. And here you'll actually see, normally it should go. That will go well, it's fine, it's technical issues sometimes. But basically you will see that there are closed corridors, kind of closed corridors. Yeah, absolutely, you see them now. So it's because of this high ceiling, we have what we call cold aisles. So we have cold air that is going through the false floor. So now we can show on this one, yeah. Oh, it's going back to the other one. So I think it's the next one, probably we have to go. So we should remove the presentation mode. Yeah, that's great. And we'll find it with one with the cooling. We have one on the cold aisles, and it's up there. And now we can put on presentation. Yeah, so we need to launch it. Haha, sometimes it happens. So it's fine. So we'll go into it, actually, into these cold aisles, and you'll see that there is false floor. So it's more or less 1 meter deep. And then you have the cold air that comes up from the floor, and then it goes on the sides to the servers, and then it's expelled, and then it's put out. So here is one of these cold aisles inside the data center. So
I can see that we got a question from social media. So the question is, can I connect my computer to the grid? And the answer actually is yes, you can. Because CERN has a project of LHC at home. And in this way, you can download a small program and you can donate free computing cycles of your computer to processing science, to advanced science. So you can calculate the same science as physicists do in the worldwide LHC computing grid. You can do it on your computer because, as we have said earlier, CERN data center contains a set of computers which are very similar to ones which you can have at home. So if you are interested in advancing science, you can contribute to the LHC at home project. You can see the web page on the presentation. It's LHC at home. .cern.ch, and you can choose to which program you will contribute. You can either choose the ATLAS experiment or CMS experiment or ALICE experiment or any other projects, for example, advancing theory by running simulations. So if you are interested in joining, please have a look at the web page and go ahead.
And it's just working while your computer is idle, so it's not taking any computing power from you, actually, which is great. So we'll be checking if we have other questions as well. So there is a question from social media as well. As the processor gets more powerful, will you need less? In fact, no, we'll see. I'll let maybe Jarka reply on this.
Okay, so it's very, very interesting that the computers are getting more powerful. But fortunately, because LHC is producing so much data, that physicists need to process and analyze. Physicists are looking, or the scientists are looking for more and more resources to be able to analyze the data even faster, maybe in more ways. So the WRCG, the Worldwide LHC Computing Grid, provides over 500,000 cores. And we invite also, let's say, opportunistic resources, resources which may be used by other experiments, by other physicists, but for some reason are idle. So we can use them opportunistically. And another way how we can expand the resources is use volunteer computing. So if you would like to contribute your idle computer to advancing science, you can, as we said, you can join the LHC at Home project and contribute to the idle computer to science.
I see that we have a question concerning what we have in the background. Yes, that's true. There are racks that are empty, and that is really part of the life of the data center. It's like a living organism. So we have many servers that are now removed, and maybe Jarka, you want to explain on this, and that we have this donation of servers that goes on. And
sure. So I will move away. In this place where I was sitting, you can see a free rack. This is some cage which will be filled. Can you enlarge it? This is the cage which will be filled with computers. You have seen a colleague putting some box inside, so we have to put the boxes inside. And the lifetime of a computer in data center is roughly 3 to 5 years, depending on the warranty conditions. And when so we are cycling, we are not replacing the whole data center at once because we need to be able to run the simulation, run the data analysis. So we are, in order to do that, we are replacing the data center equipment by parts. So roughly one quarter each year. And when the equipment is to be removed from the data center, we do not throw it away into trash. We donate it to institutes worldwide to promote science and contribute to science whenever possible. And these donations happen each couple of years or each year.
Yeah, exactly. We've been donated to 9 countries so far. I think the last one was Mexico, actually. So
yes.
Oh, we have many questions actually coming from the social media. There is one asking, what operating system do you use the most for the data center?
Okay, so it depends on the purpose for which the computer is used. In the whole CERN, we have various of Linux operating system. We can have Windows desktop computers. We can have Windows machines for example, administrative applications. And we can have also Mac computers for as a desktops or laptops. Now, what concerns the data center, most of the machines which are running scientific calculations are running scientific Linux, which is clone of the GNU Linux operating system. And we are currently running SL Scientific Linux version 6. In the next year, because there is, let's say, life cycle of Scientific Linux is about 5 years, and this current version is to be obsoleted in 3 years from now. We are moving to the next major version, which will not be Scientific Linux, but it will be Linux based on CentOS clone. So mostly the data center for computations of processing of data of LHC or analysis of data is running Linux.
Yeah, that's great. Do you have some questions in the meantime? Something concerning what you've seen, or we can take as well other questions from social media. It's really up to you. There are only good questions. Feel free to.
Thank you. There doesn't seem to be a question at the moment. We are just a bunch of people, but thank you for the presentation. If there are further questions on social media, that's up to them. Thank you.
Thank you.
Thank you.
I can see there is another question from social media. How many PCs are there on the grid? So currently on the worldwide LHC computing grid, there is over 500,000 processors. So you can say it's about that in PCs. My laptop has a hard disk of about 250 gigabytes. So we have a bit more storage space on the worldwide LHC computing grid than this. We have several hundreds of petabytes of data. 1 petabyte of data is about 250,000 of DVDs. Or if you want, for example, 70,000 smartphones or iPads. So this is really very huge storage capacity.
Oh yes, I think we have now just passed the 170 petabytes mark on tapes actually. So it's
wow,
100 petabytes on disk. So it's kind of a lot.
It's a lot.
And a lot of smartphones.
Tape is not the only storage medium. Tape is the, let's say, long-term medium. When physicists run their analysis, they use disks, either the hard disk, like the spinning disk, or SSD, solid-state disks. Just because we need some very fast media to access. If you would like to store data on tape, it takes about 1 to 2 minutes to make the tape ready, just to read file or write file to tape. And if you are running analysis, waiting 1 minute for some resource, it's taking a bit of time. So we are using disks as either a spinning disk or the solid-state disks to access the data. Now, another question from social media is, how long do you keep the data? So the experiments, the design of experiments started about 20 years ago. And when you are designing experiment, you have to run some simulations to have material to support that your physics program makes sense, and you have to make some initial studies. So we have, in some sort, we have data which is already 20 years old. Now, data taking on LHC started for the first time in 2008. Then we had the problem with magnets, and we started in 2009, 2010, and we are running ever since. Now, at the moment, we are in the 7th year of data taking. So we already have 7 years worth of data. It's, as Mélissa said before, it's over 170 petabytes of data on tape, and tape are roughly 15-20% of the storage capacity. So we are really very close to exabytes of data. Now, what concerns the long-term storage, as you can imagine, over 20 years, the software used for analysis the software is evolving over time. If you are running physics analysis as a PhD student or scientist, you can have a different version of your analysis package each night or several times per day. And the whole collaborations of the experiments of Atlas, ALICE, LHCb, and CMS, they have software builds which can evolve also every day. And it's really very hard to keep track. And in order to be able to analyze the data which we take today, in 20 years later, or in 50 years later, or 100 years later, there is activity about data preservation, because not only we have to keep the data safe in several copies around the world, not in the same data center, because of natural disasters. When there is a hurricane in one data center, you do not want to lose all the data which you have taken for 7 years in a row. You need to have a backup. So we are creating backups of data. We are storing them long-term on tapes. And for the tapes, each of the data centers which have tape robot or tapes for data storage, we do not just record the data to tape and leave it alone. We can read it out of the tape. The tape can get destroyed or corrupted. So we need to be able to check that the data is still available to us. So we are rewinding the tapes and reading the data and making sure that everything which is stored on tape is stored safely.
And the density actually is becoming higher, which is really good for us, because every 3 years we are rewriting, as you were saying, the tapes on new tapes, which are with far higher density. And then the very good point is that we are, for instance, a year and a half ago we had more than 50,000 tapes, and then for the same quantity of data now we have 25,000 tapes. So this frees space to save new data from the experiments, and that's the way it goes, and we are able to cope with the rate of data taking actually. There is a new question. It's concerning Budapest, so that's great. Why do you have a data center at the Wigner Center in Budapest, Hungary? So actually there are two, as far as we know, because there is the extension of the CERN data center, so the tier 0 of the worldwide LHC computing grids, and it accounts for more or less 1/3 of the tier 0 capacity, so it's really something important. And there is as well a tier 2 center. So the worldwide LHC computing grid starts from, so you have the tier 0 center, which is CERN and Wigner together, and then you have tier 1 centers. It's about more than 12 centers in the world. These centers have a copy actually of the data that we have at CERN. So we are seeing now live the worldwide LHC computing grid. So it makes it more concrete, I think, which is nice. And this you can show thanks to the CERN dashboard for the worldwide LHC computing grid dashboard. So you add a line of coding to the Google Earth thing, and then you can see live what is happening. So everyone can see that from home if you want. So it's really 2 million jobs. It's really a lot per day. And you can see that it's really very, very active. And so we have then these tier 1 centers and then tier 2 centers, more than 140, 150 of them. And then Wigner is again one of those. And it's where the analysis is actually done for the data, where the processing is done.
Okay, I have a couple comments what you can see. So in here on the left part of the image, you can see the CERN. And in here, you can see Fisherman and Beston's institutes which are sharing the Wigner data center or the data centers in Budapest. And each of the green lines, which you can see, is a transfer of data. Because when physicists run their computational jobs, the jobs can run at over the 150 or 170 computing sites distributed worldwide. And when the job finishes, the physicist needs to read the data and use it for their analysis. So what is happening is that the output of the job is transferred from the original site to CERN, and then physicists can access it. Physicists can access data not only at CERN, they can access data at each of the sites which are distributed worldwide. So you can really do planet scale analysis as a high energy physicist.
Well, we see that there are nearly 150 people on the webcast, so many thanks for joining us. Thanks a lot to everyone. That's really, really nice. That's great. I don't know if there are some questions that you may have by having seen this, or if there are other topics you would like us to cover. Ah, I see one. So why the web? Oh, sorry, if you have one, yeah, sure.
I'm trying to catch the camera. Thank you for the presentation. We have about a couple of minutes more left because we will have another program starting.
Sure, no problem. We have many questions. That's fine. Thanks a lot for having joined us, and we will keep going with the questions.
Thank you.
Thank you. Goodbye. So from the questions we have, there is one: why the web was invented at CERN? So yes, why? So actually, it's really related to the community we have. So there are 10,000 scientists collaborating with CERN. And when you have such a big community, how can you make sure you have an efficient communication and you share information as quickly as possible? And that's really what actually apparently was motivating Tim Berners-Lee in '89 to do his proposal. The one you've seen on the screen with the mention from his supervisor, which was vague but exciting. And indeed, it was really exciting but vague, maybe at the time, because it was very new. And that's kind of something that is really related to the way we work, the collaborative aspects.
Collaboration, because as we have said, the scientists which are analyzing data produced at the LHC experiments, these are people who are living not at CERN, not only at CERN, but all in the whole world. So they need to be able to communicate efficiently, and this is why World Wide Web started, because of the communication needs of the scientific community.
So there is one more question related. So it's why CERN did not sell the web? So actually, it's not in CERN's DNA. So we've told you it's about really collaboration, and to make it open and free, it had to be protected, which CERN did. And that's why we can all use the web now, and we are not having many different proprietary solutions. And we can have this homogeneous system that is enabling us to communicate so well. I think we've covered many questions. I don't know if there are still questions going. We'll have a look. Yeah, I think we are now running out of questions. So thanks a lot for having joined us. So Zoltán, who have just left, and as well for all the people who've joined the webcast. It was really nice of you. Thanks a lot. There are many sites actually to visit at CERN. So if you go to Geneva, feel free to check the CERN website. There is a visit service and you can book a tour, an online tour, and the tour on site. And there are free entrance exhibitions as well. There are 2 of them. There are some visiting exhibitions as well that may come to your country. And we welcome as well a lot of trainees, students, graduates, staff people. So we recruit many people as well. So we encourage you to have a look to the recruitment website as well. And the website for the visit is actually cern.ch/visits. And the next virtual tour will start at 9. This is the ALICE experiment and detector. So it will go Geneva time. Yes, sorry. Yeah, this is a webcast, so you come from all over the world. So we encourage you to join. Thanks a lot.
Thank you.
Thank you.
Bye.
Bye. Goodbye.